Dealing with frozen plumbing vent pipes in extremely cold climates requires careful consideration of several options. Firstly, a heated vent cap can be installed. This device incorporates a heating element directly into the vent cap, preventing ice buildup at the point where the vent exits the roof. It requires a constant electrical power supply to operate, so proper wiring and weatherproofing are essential. Secondly, heat tape can be wrapped around the exterior of the vent pipe. This is a common solution, involving wrapping specialized electrical tape around the pipe, both in the attic and above the roofline. The heat tape generates warmth, preventing the pipe from freezing. A thermostat is typically used to control the heat tape, activating it only when temperatures drop to a certain level. Thirdly, a heat probe can be installed. This option involves drilling a hole in the vent pipe inside the attic and inserting a capillary tube-type heat probe upwards into the pipe. This probe is connected to a heated reservoir or some other means of generating heat, such as a small electric heater. The heat is then circulated through the probe, warming the vent pipe. A heat transfer fluid or glycol solution may be used to improve heat transfer. It is important to ensure that the heat source is rated for outdoor use and adequately protected from freezing. Fourthly, heated insulation can be installed. This involves using specialized insulation materials that contain heating elements. The heated insulation is wrapped around the vent pipe, covering both the attic and roofline sections. It can be powered by electricity or a heating cable system. Fifthly, focus on insulation and ventilation. Increasing the amount of insulation around a vent pipe will minimize heat loss. This can be achieved by wrapping the pipe with fiberglass, foam, or other insulating materials. Improving attic ventilation can also help to prevent moisture buildup and freezing. Proper ventilation allows warm, moist air to escape from the attic, reducing the risk of condensation and ice formation. Some key considerations for any of these methods are electrical safety, maintenance, and energy consumption. Use ground fault protection breakers for all electrical components to protect against electrical shock. Ensure that all electrical components are properly installed and weatherproof to prevent damage from moisture and ice. Regularly inspect and test the heating equipment to ensure proper operation. Look for any signs of damage, such as frayed wires or cracked insulation. Check the thermostat to ensure that it is working correctly. Consider energy-efficient options to minimize operating costs. Use timers or thermostats to control the heating equipment. Insulate the vent pipe and attic to reduce heat loss. Be aware that the costs of installation and operation will vary depending on the chosen method and the size of the home. Obtain quotes from multiple contractors before making a decision. Factor in the cost of electricity or other energy sources. Some additional tips to consider are installing a vent alarm. This alarm will alert you if the vent pipe becomes blocked. Provide easy access to the attic and roof for maintenance and repairs. This will make it easier to inspect and repair the heating equipment. In extreme cold conditions, it may be necessary to supplement the heating system with a temporary heat source such as a portable heater. This can help to prevent the vent pipe from freezing in especially cold weather. When considering these options, it is important to prioritize electrical safety. The risk of electrical shock is a serious concern when working with electrical heating systems, especially in damp environments. Therefore, always use ground fault protection breakers to protect against electrical shock. Ensure that all electrical components are properly installed and weatherproof to prevent damage from moisture and ice. Hire a qualified electrician to install any electrical wiring or equipment. Regular maintenance is also essential for ensuring the long-term effectiveness of any heating system. Regularly inspect and test the heating equipment to ensure proper operation. Look for any signs of damage, such as frayed wires or cracked insulation. Check the thermostat to ensure that it is working correctly. Clean the vent pipe regularly to remove any debris that may be blocking it. Energy consumption is another important factor to consider. Heating systems can consume a significant amount of energy, especially in cold climates. Therefore, it is important to choose energy-efficient options to minimize operating costs. Use timers or thermostats to control the heating equipment. This will allow you to turn the heat on only when it is needed. Insulate the vent pipe and attic to reduce heat loss. This will help to keep the vent pipe warm and prevent it from freezing. The cost of installation and operation will vary depending on the chosen method and the size of the home. Therefore, it is important to obtain quotes from multiple contractors before making a decision. Factor in the cost of electricity or other energy sources. In addition to the above options, there are a few other things that you can do to prevent frozen plumbing vent pipes. Keep the attic well ventilated. This will help to prevent moisture buildup and freezing. Seal any cracks or holes in the attic to prevent cold air from entering. Install a wind turbine on the roof. This will help to draw warm air up from the house and out of the vent pipe. In conclusion, preventing frozen plumbing vent pipes in cold climates requires a combination of careful planning, proper installation, and regular maintenance. By considering the options outlined above, you can help to ensure that your plumbing system remains functional even in the coldest weather. The installation of any heating device for the vent pipe must meet local and national electrical codes, specifically Article 427, electric de-icing and snow melting equipment, of the National Electrical Code. The NEC provides detailed requirements for the installation of electrical heating systems, including those used for de-icing and snow melting. It covers aspects such as wiring methods, overcurrent protection, grounding, and control. Article 427.4, titled Use is not permitted, states that de-icing and snow melting equipment shall not be installed or exposed to severe physical damage unless adequately protected. This means that any heating elements or wiring must be protected from impact, abrasion, or other forms of physical damage. Article 427.5, titled Complete Coverage, requires that the heating system cover the entire area to be protected from ice or snow. In the case of a plumbing vent pipe, this means that the heating system must extend from the point where the pipe exits the building to a point above the expected snow or ice level. Article 427.6, titled Non-Heating Leads, specifies the requirements for the non-heating leads of heating cables or tapes. These leads must be suitable for the voltage and current of the heating system and must be protected from physical damage. Article 427.11, titled Guarding, requires that heating equipment be guarded to protect persons from accidental contact. This may involve the use of enclosures, barriers, or other protective measures. Article 427.12, titled Disconnecting Means, requires that a disconnecting means be provided for the heating equipment. This allows the power to the heating system to be shut off for maintenance or repair. Article 427.13, titled Overcurrent Protection, requires that the heating equipment be protected by overcurrent protection devices such as circuit breakers or fuses. These devices protect the heating system from damage caused by excessive current flow. Article 427.14, titled Grounding, requires that the heating equipment be grounded to protect persons from electrical shock. This involves connecting the metal parts of the heating system to a grounding electrode, such as a ground rod or metal water pipe. Article 427.16, titled Installation of Heating Cables on Exterior Surfaces, provides specific requirements for the installation of heating cables on exterior surfaces, such as plumbing vent pipes. These requirements include the use of weatherproof materials, proper spacing of the cables, and protection from physical damage. Article 427.17, titled Installation of Heating Cables in Masonry or Concrete, provides specific requirements for the installation of heating cables in masonry or concrete. These requirements include the use of suitable heating cables, proper spacing of the cables, and protection from moisture. Article 427.18, titled Tests, requires that the heating equipment be tested after installation to ensure that it is operating properly. This may involve measuring the resistance of the heating cables, checking the thermostat, and verifying the operation of the disconnecting means. In addition to the NEC requirements, local electrical codes may also apply. These codes may vary from one jurisdiction to another, so it is important to check with the local authorities to ensure that the installation meets all applicable requirements. When installing any heating device for a plumbing vent pipe, it is essential to follow all applicable electrical codes and safety guidelines. This will help to ensure that the installation is safe, reliable, and effective. Remember to consult with a qualified electrician to ensure the installation meets all code requirements and is safely implemented. Consider the long-term implications, including energy costs and maintenance needs. Weigh the cost of installation against the inconvenience and potential hazards of manually clearing a frozen vent pipe. Remember that safety is paramount and any electrical work should be performed by a qualified professional.